Okay, let's go over this for 6 weeks review. I already have all the problems worked out, so I'm just going to be explaining them. Hopefully you have already tried your review and are just checking your work. That is the best way. But if there's a problem that you just had no clue how to do, then hopefully me going through this will help you understand. Okay, so we have the schoolhouse down below, and it tells us that the measure of an interior angle is 135. That means one interior angle is 135. I want to find the number of sides the schoolhouse has. Okay, I have two ways that I could do this. I could use the formula n minus 2 times 180 divided by n, which is the formula for finding one interior angle. And since I know that one interior angle is 135, I could set this equal to 135, pop it over a 1, and cross multiply, divide, work it out. The way I decided to do it is, if I know what the interior angle is, I decided to find the exterior. So to find the exterior angle, I take 180 minus 135, because interior angles and exterior angles, interior and exterior angles, they always add to be 180, so that's why I did that. So my one exterior angle is 45 degrees. And then I use the formula for how you figure out one exterior angle. If you want to know one exterior angle, you use 360 divided by n, the number of sides. And since I know that one exterior angle is 45, I set the 360 over n equal to the 45. I pop the 45 over a 1, and then I cross multiply and divide, and I solve my proportion, and I get that the floor has 8 sides. I'm going to shrink this down just a little bit because we can't quite see everything. Okay, so I did have two ways that I could go about it. I could use the one interior angle formula, set it equal to 135, cross multiply, work it out, or if I know an interior angle, I can take that interior away from 180, get the exterior, and then I can use the one exterior angle formula and set that equal to what I know it is and work that out. So whatever you think is easier. Okay, this next one, we want to find the sum of the measures of the interior angles of a nonagon. So first of all, I know a nonagon has 9 sides, and so I want to use the formula n minus 2 times 180, and I know n is 9, so I just plug the 9 into the n, and I get 1260 degrees. Okay, next one. This is a parallelogram, and I know in a parallelogram that opposite angles are congruent. So in a parallelogram, our opposite angles are congruent. So I set these two angles equal to one another, and then I set these two angles equal to one another. And then I just solve for x and I solve for y. So this is review from a while back. So in a parallelogram, opposite angles are congruent, opposite angles are congruent. And then just solving two easy equations right there. Okay, next picture. This is a rhombus. So think about what you know about a rhombus. I know in a rhombus that all sides are congruent. So I just wrote that down. All 4 sides are congruent. And then if they give me the length of AB and the length of BC, I know that these two sides are congruent. So I just set them equal and I solve. And there it is. I get that x is 1, and that's all they wanted to know about was x. Always be careful. Make sure you find what exactly it is they're looking for. So because it's a rhombus, I know all 4 sides are congruent, so I just set them equal. Okay, next problem. It gives me a picture, and I want to know what the measure of angle F is. So first, I need to figure out what all these angles add up to be. So it's got 1, 2, 3, 4, 5, 6 sides. So I'm going to use my formula n minus 2 times 180 to figure out what all 6 angles inside should add up to be. So I plug the 6 into the n. That makes 720. So I know all of these angles should add to be 720. So this is the equation I get when I combine like terms. So I combined all my x's, my 10x, my 10x, my 5x, my 5x, and then I combined all the constants, the 134, the negative 4, the positive 8, the positive 8, the negative 4, the 128. And then all I have to do is solve for x. And then because it wants to know angle F, I just plug the 150 back into the x for angle F, and that makes 1496. Please feel free to pause me at any time if you actually need a little more time to think about this problem or just time to work. And if you have to rewind me. No big deal. Okay, next problem is a Venn diagram, and I'm trying to figure out about sometimes, always, or never. Number 6 says, a parallelogram is a square. Well, a parallelogram can be a rhombus, a parallelogram can be a rectangle, a parallelogram can be a square, so that would be sometimes. Okay, this next one. A square is a rhombus, and that is always. All squares are both a rhombus and a rectangle. So all of our squares, which are right in here, are both a rhombus and a rectangle because it's the rhombus and the rectangle circles that overlap in the square section. So that is always. A square is always a rhombus. A square is always a rectangle. Okay, the next one says a rectangle is a parallelogram. A rectangle is a parallelogram. Your parallelograms are rhombuses, also rhombi, sorry. Your parallelograms are rectangles. Your parallelograms are squares. That is true. A rectangle is always a parallelogram. So always. Okay, next page. Number 9. I want to know the measure of an interior angle of a regular hexagon. So if I ever want to know one interior angle of a regular, any kind of polygon, I use the formula n minus 2 times 180 divided by n. And since a hexagon has 6 sides, I take 6 minus 2 times 180 divided by 6. Another way I could do this is instead of finding the interior angle first, I could find the exterior angle first. So if I wanted to know the exterior angle first, I would take 360 divided by how many sides? And since a hexagon has 6 sides, I would divide by 6. And I could get the exterior angle first to be 60. And if I want to know the interior, I just take 180 minus my answer and get the 120. So it doesn't matter which way you do it. Either my first way, just find the interior straight up the first time, or the second way, find the exterior angle first, because it's a slightly easier formula. And then once you know the exterior, take it away from 180, and you've got your interior. Okay, number 10. This one is easy. All my sides are congruent. All my angles are congruent. So this is a regular shape, and it is convex. Concave is when the shape caves in and diagonals can be drawn outside of the shape. So this is convex and it is regular. Okay, number 11. I want to know which figure has all sides of equal measure but not necessarily all angles of equal measure. And this is our rhombus. I know that a rhombus has all 4 sides congruent, but not all the angles inside are the same. A square is the other shape that has all sides congruent, but in a square, all the angles are 90 degrees. And this says not necessarily all angles of equal measure. so it is the rhombus. Okay, number 12. This is a regular octagon, so I know all the exterior angles will be the same as one another, and all the interior angles will be the same as one another. So is angle X here interior or exterior? Angle X is exterior, so since it's an exterior angle, and I just am interested in just that one, I can take 360 divided by however many sides the shape has, and since the octagon has 8 sides, I can divide by 8, and I get 45. And of course I could have done this differently. I could have found the interior angle first. I could have found this interior angle right here by using the formula n minus 2 times 180 divided by n. And then once I know the interior, I could take it away from 180 and get the exterior. So I could do that. Okay, page 13, or problem number 13, sorry. This is irregular and it is concave. It caves in. I have a diagonal that can be drawn outside of the shape, so that's concave. And it's irregular because not all my angles are the same. This angle from here to here is definitely not the same size as the angle from here to here. So I don't know if all my sides are congruent or not, but I do know that all my angles are not congruent because this angle is much, much bigger than that little tiny angle. So it is definitely irregular. Okay, this next one, the trapezoid. It's been a while. We learned that whenever we have the median of the trapezoid, the median always equals the top and the bottom of the trapezoid added together divided by 2. So the median of the trapezoid, 12, equals the top and the bottom of the trapezoid divided by 2. And then I just pop my 12 over a 1, I set up my proportion, and I cross multiply and divide. So 2 times 12 makes 24, and then I clean this up to get 3x minus 6, and 3x minus 6 times 1 is 3x minus 6. And then I get an answer of x equals 10. And the question wants to know what's the length of AB. So I plug the 10 back into the x, and I get AB to be 5. So pretty easy, but it has been a little bit since we've done that. Okay, number 15. This is a parallelogram, and I know it's a parallelogram because the top and the bottom are parallel, and the 2 sides are parallel. So anytime you have 2 sets of parallel sides, that's called a parallelogram. And in a parallelogram, I know that my consecutive angles are supplementary. I remember that my opposite angles are congruent, but my consecutive angles, those are supplementary. So I set 2x plus x to equal 180. I combine like terms, get 3x is 180, and when I divide, I get x is 60. Okay, and this next problem down here, it talks about a rectangle, and it talks about the lengths of the diagonals, and in a rectangle, I know that the diagonals are congruent. So I made a note of that off to the side. Whenever we have a rectangle, the diagonals are congruent, and so if the diagonals are congruent, all I have to do is set the 2 diagonals equal to one another. So 4x plus 10 equals 5x minus 20. Okay, when I solve for x, I get x to be 30. And then it actually wants to know what is the length of one of the diagonals. So I just decided to plug my 30 into that x and work it out, but I could have put 30 in this x. It doesn't matter. And both diagonals will be 130. Okay. Number 17. I'm going to split this video into 2 parts just because it's going to get kind of long, and also because the bell for 7th period is going to happen in, I don't know, 5 minutes or so. So let's see what I can get done, and then whatever I don't get done, I will put in a second video. Okay, here, I want to know if the diagonals are perpendicular. So if I drew in the diagonals, if I want to know if these diagonals are perpendicular, I need to know something about slope, because if segments are perpendicular, I know their slopes are opposite reciprocals. And so I would want to know something about slope. If I use the distance formula, I could know if they're the same length or not, but I want to know if they're perpendicular. So to know if they're perpendicular, I need to know if the slopes are opposite reciprocals. So slope is all I'm interested in calculating. Okay, 18 and 19. This is pretty recent stuff. This was in our last test that we took. Number 18 wants to know the area of the sector. So I know if I want to find area of a sector, an area of just a piece of the circle, that I need to know area of the entire circle. So I use that formula off to the side. Area equals pi r squared. I know my radius is 2. So pi times 2 squared is 4 pi. So that's the area of the entire circle. I want to know just the area of this piece here. So I'm going to talk about how many degrees is it out of how many degrees in the whole circle, what's its area out of the area of the whole circle. And this is the proportion that I would set up. It's 90 degrees out of the 360. What's its area out of the area of the whole circle? And the area of the whole circle, remember, was 4 pi. And then I just cross multiply and divide. And when I put this in my calculator, I don't even put the pi in there. I just take the 90 times the 4, get that answer, divide by 360, and whatever answer I get, I put the pi back behind it. Okay, 19. Same kind of question, except for I had to draw the picture. We want to know the area of a sector if the radius is 10 and the central angle is 72. So here's my 72 degree central angle. My radius is 10, and because I want to know the area, I need to know the area of the whole circle. So pi times radius squared. My radius is 10, so pi times 10 squared is 100 pi. And then I just set up my proportion. How many degrees is the arc? 72. Out of how many degrees in a full circle? 360. And then what's the area of the sector? X. Out of the area of the whole circle? 100 pi. And then I cross multiply divide, and I get an answer of 20 pi. Okay, we'll stop here. My next video will be 20 through the end. Thank you.